I guess we're going to start now. First of all, thank you so much for coming to attend Big Data and Predictive Analytics for AML and Financial Crime. How many of you guys are from financial services? Okay, good. And so we're going to cover some bases because we have a lot of people who does not have the backgrounds. So it's good to kind of level set before getting into too much detail. And I'll try to keep around 10 minutes towards the end for question answers. So if we can keep the question answers toward the end, that would be great. This is a high-level agenda which I will be covering, idea here is to kind of show you guys art of possibility, what people can do that with the platform now, and that's the kind of key focus around the whole discussion. As far as my background is concerned, I have over 20 years of experience, spent over 15 years within financial services industry, and been with Hortonworks for about 4 years. And in these 4 years, I've been working with practically all large financial institutes to adopt big data. I'm field CTO of Hortonworks, as well as I led the technical alliances team. So kind of wear multiple hats, data has been my passion, and as well as how to get value out of the data is the next big thing where we're gonna kind of trying to focus on. So just to kind of level set, when people talk about financial services, what exactly it means. Financial services has a number of verticals. It's not just one giant thing which kind of do everything. Within that, they have different classifications of line of businesses. There's a capital market, there is a retail banking, there is a payment system, credit card and stuff like that, and there is a market exchanges and stuff like that kind of thing. So when people talk about financial services, the very next question should be that which part of the bank you are working for kind of thing, to fully understand. But the interesting thing about that is no matter which part of bank you are trying to do, one way or another you are dealing with the AML, and that is where it make it a very, very unique and interesting problem that you have to make sure that when you're building and setting up any kind of enterprise anti-money laundering kind of platform or any scenarios, you need to make sure that it covers across all the verticals. If you don't do that, your platform is not complete, and this is one of the things which we're going to talk about as part of the discussion. In terms of financial services, these are the 5 main trends which we are seeing across the industry. Predictive analytics, machine learning, deep learning, and this is where across all those verticals, what I was showing you guys, it is kind of getting right now explode across all those industries and verticals. Digital banking, everybody want to kind of move towards Bank 3.0 and Bank 4.0 scenarios. What is Bank 3.0? Essentially, it's all about how to digitalize every channel through which you are getting the data, every channel through which you are communicating with the customer. That is what it means when you're talking about digitalizing the bank. When you do a text, use a messenger to interact with the bank rep, how that information are getting used in a long term to make sure that you are happy. That's a simple example of that in terms of when people are talking about what is the digitalization of banking kind of thing. Capital market is, again, majority of the trading, investment management stuff happen in capital market, and over there the focus is that how to leverage big data and other data sets to their advantage when they are trying to kind of explore the different possibility within the market space. Wealth management is all about individual customers as well as your retail customers, how you interact with them, how you try to get value out of them. Cybersecurity is always a big topic, and that's another area where a number of people are focused around that. And I'm sure cybersecurity is the area where it should be on everybody's mind at this point, because as you can see that it can have a huge implication. You have seen recently WannaCry virus, and those kind of things are happening. So why to use big data for financial crimes and control? That's one thing which, if you go back to the slide where I started, you have different verticals. And if you know that every business has a silos, that everybody want to kind of keep a control of their data within their own universe. And what essentially it means is that when you want to do anything related to compliance, anything related to regulation, what regulators are asking, I want to see the full picture of the firm. I don't want to see what exactly happened to you in capital market or a credit card processing unit. I want to see what is the overall exposure you have as a unit. In order to show you guys that how big is the money laundering problem or financial crime is a problem, this is a $1 trillion issue or problem which people have. And what AML become very unique is that, how many of you guys have credit card? Practically everybody has credit card. The best thing about credit card is that if your card gets stolen or if somebody else is using, you know that. With money laundering, you don't know that if that kind of fraud has happened to you or not, which make it a very, very tricky and unique situation. That there is generally, unless somebody report or somebody else figure that out, they will say, oh yeah, this is a money laundering case. So financial crime is commonly considered covering the following areas. When people talk about what is a financial crime, your credit card fraud, your opening up an account with the false IDs and stuff like that is a fraud, money laundering, terrorist financing, bribery and corruption, market abuse and insider trading. All those are different varieties of financial crimes. And ultimately, as a bank, as an institute, you need to kind of fight with each one of them. And the best thing about that is that a lot of these things are not just only applicable to financial services, they are applicable across other industries as well. When you're talking about some of these things, you really need to think about that, how these things can be applied to a non-financial services industry as well to be more profitable. So in a survey, just to kind of show you that how big is this whole market space and how big is the problem itself, almost 58% of businesses have been victim of fraud one way or another at different time in their life. And 80% of the bank failed to stop a transfer which was fraudulent or which was related to anti-money laundering. 87% of fraud attacks, the bank was not able to fully recover the data or fully recover the amount. 40% of and what is the impact of all these things? You're going to have an impact not only on monetary side, but also you're going to have an impact on reputation. You're going to have an issue and problem with the compliance. So So problem is not just limited to only that, oh yeah, bank has lost some money, I'm gonna just report that as a loss. No, it is beyond that. This is what you really guys need to think about that when you're thinking. So investing in this space, go back to $1 trillion with all these things, you see that this is a huge space and huge problem which has to be solved. So just to kind of level set, I have a couple of examples of use cases to kind of give you an idea that when people are talking about AML and financial crime, it is touching a lot of different data sets and different problems, which could be very, very unique and touching practically every data set which you have within your bank. One other thing, a term which gets used heavily in financial services is that KYC, know your customer. KYC stands for know your customer. And essentially that is a foundation what your regulators are asking you to figure that out when you are opening an account with a customer, from where it's coming from, what exactly is the motive, what essentially is going to be doing. You really need to kind of keep track of all those activities. And now with everybody having a global access to information, it becomes very, very challenging that that person might have an account which is part of 10 different geographics or 10 different countries. You have an account. How are you going to link all those things together to figure it out what essentially is doing with whole, think about it's a complex graph kind of thing, which is building, you have to build to figure that out. It is a huge data mining problem to start with. So in this particular example, a customer is trying to move the money. He has a public portfolio, and within a very short period of time, he's trying to do a number of transactions, how to flag those. And one thing which probably, I'm sure when everybody open an account, they realize that you provide your information at that time that, yes, I'm working at company XYZ, but after that, nobody knows that what essentially happened. If you change your job, go to do something else, if you commit any crime, there is no information bank has about any of those things, except if it goes to credit bureau and other things. They might know about those things, but otherwise they will have no idea about what exactly is happening. So this is another reason. The second use case is that multi-product linked accounts. What essentially it means is that if you look at that, I have retail bank, I have a credit card, I have a stockbroker account, and they are in 3 different groups. How I'm going to combine those together when I'm trying to figure that out, that whatever the activity that person is doing, that they are not fraud activities kind of thing. And the key thing which is very important, like if you look at that in this slide, it tries to kind of highlight what data set I need to figure that out and what kind of analysis I need to do. A lot of time people talk about a single view of a customer, single view of entity and stuff like that. With AML, you are developing that single view of a customer in a kind of 3D manner. It is not just one way to drive the whole single view of customer. You are trying to drive that whole information in a variety of different ways. And that's the key thing which is, as I mentioned it earlier, like this is probably one of those activities which if you don't find it, it's going to go unnoticed. And what is the impact of that? Probably you will never know. The third use case is a more around the fraud, that people are getting false identity and opening up accounts and then trying to build credit history, trying to build a credit card around that, and then leveraging that information to do your money laundering and other activities like that. And as you can see that, this is where now you are trying to build a single view of similar entities. People are having hard time building a single view of entity. Now you have to build a single view of similar entities. You're trying to do something which is very, very interesting. It's getting to a point where humans can't do that effectively. That's the point I'm trying to make here. Social network analysis. One way to figure that out, that what essentially that person is doing on social media. Like anytime when there is something bad happen, the police, FBI try to look at that person's social media posts, YouTube, Facebook, Twitter, everything. And a lot of time they find some clues. And that's exactly the case is with your financial crimes also, that you can find patterns. You can find information which could lead towards certain kind of problems. And then there is another set of data which is also you need to think about when you're talking about fraud kind of activities, that government has watch lists which is constantly getting updated. You need to do a text mining about that information. So you need to, when you are doing this kind of analysis, you always need to have a data. So if you look at that in those 5 use cases, I show you at least 15, 20 different sources of data which you need to kind of even start thinking about how I'm going to build a AML-based kind of solution. And each data has a different variety. Some are structured, some are semi-structured, some are unstructured. And one of the biggest problem, I don't know if you guys have noticed or not in that, there is no automatic linking. There is no linkage between the information which you see in 5 use cases. When you open 3, even within a single bank, when you open 3 accounts, you will get 3 different IDs. You open a brokerage account, retail account, very rarely the bank is going to try to attach them. Now they are doing that, but if you look at historically, that was not the case. So what is the general trend which we are seeing in AML? So as you can see that, based on what I talk about that, the analysis around these things is not a simple. You have to have a very rich UI to be able to kind of deal with the data set. You need to have a way to kind of drill down into information seamlessly. Very important. You need to kind of have a constant update. That's one of the key things. One of the things which people think about that, yes, I have implemented AML solution. My solution is now I'm secured. One thing they are not realizing that your AML, your criminals are actually much more advanced now. They have much more information and they are constantly evolving. They are very, very sophisticated in a lot of cases. Look at that, what exactly happening right now with false news and everything, whatever people are talking about, that even companies like Facebook and those are having problem to filter out which is the real news and which is just a bad news kind of thing. And they are one of the early adopters of whole machine learning and those techniques. So as I mentioned that, you are dealing with a highly sophisticated criminals here. When people can go ahead and block majority of systems based on a typical type of operating system, that shows that and still can't be traced. That shows the maturity of those criminal and the kind of expertise they have. So, and a lot of time when these activities are happening, it is not within a single region. And yes, there are now rules that if you have an account in other country, you have to report in your taxes. But how many, do you think that if somebody is a criminal, he's going to do that? It's all, right now, you're having those rules for good citizens. But the people who has a criminal mind and those activities, they are very easy to kind of exploit those systems today. So just to summarize, essentially what we talk about that you don't have a single book of records. Every department, every unit in a department has a different way to treat the data set. You have a separate system across geographic. If within, forget about like different line of businesses. Within a single line of business, you will see there is a high probability that they will have a separate database for US, separate database for Europe, and multiple databases for Europe and multiple databases for Asia. And due to regulations, it makes it even harder to even collaborate between them because there are regulations in those countries, the data cannot leave. So I'm sure you guys are aware of that, a lot of countries in Europe, and for example, China and Middle East, the data cannot leave those countries. How are you going to do effective AML or any kind of fraud detection when data is not easily available to you guys? So your solution need to be kind of based on a framework which you can apply everywhere and aggregate information. Because aggregation of information and sharing is not a problem. Problem is sharing of the raw information. And also, the amount of data which we are talking about is kind of not practical to even share. If you say, I'm going to bring all my data from Asia and Europe to US and do analysis on that one, good luck with that, because you are moving so much data over the WAN. You're going to have a kind of issues with how long it's going to take you to process that information. And I said, like, you have multiple general ledgers, you have multiple, there is a separate AML today for retail, separate AML for commercial lending, separate AML for capital markets, because data is not being shared. And talk about that, majority of the systems are still running on end-of-day data, best case scenario. Nobody is thinking about how you're going to handle the real-time scenarios. And even though people realize that if I put everything in a single platform, I can do a lot more than that. It is just the culture of the institutes as well as technology limitations are stopping people to do something like that. Because one of the biggest concerns is that capital market does not want to share data with retail because data has information which they cannot share. And they're worried about that if I'm going to store them in a single data lake, data is going to get exposed to everybody. So these are some of the kind of limitation. And one of the biggest limitations I see when I talk to customer, when you kind of implement a third-party solution, it does not have flexibility. There is no easy way to kind of have an open platform. That if I want to kind of write my own predictive analytics or machine learning and do something with that, I can't do that. So now let's talk about, we talk about a lot of kind of context and stuff like that. Let's talk about how people are trying to solve this problem. What is the ideal way to kind of handle that? So one of the very first thing is that when you're thinking about, you have to think about a platform which can handle both structured, unstructured data, can handle real-time data, can handle end-of-day data, should have a provision to secure the data, whatever is not, anonymize the data set, because when you want to bring system from other countries, if you anonymize, you can still bring it. You cannot bring it in original format, raw format. So these are some of the data sets which you need to start with. So very simple things from where you are starting, you really need to figure it out. What are my data sets which I need to kind of worry about? When I'm talking to the line of business, these are things which I should be thinking about. And how do you kind of handle, you need to think about a solution which can handle vast variety of historical data. Um, it has a way to deal with business rules, and I'll cover that. Business rules play important role when AML come into picture, because when you are trying to adopt any regulation, you need to make sure that you are following certain regulations, and that's one of the key foundation around that. And you really need to kind of keep, when you're building a platform, you really need to keep it open. What do I mean by open? I mean, to say open is that today I'm using, for example, Spark. Tomorrow, if something is better than Spark, on the same data which I stored in that format, I should be able to plug in some other engine seamlessly without much problem. That's called open system. Because think about that, one of the slides will cover that. The data, when you start building this data lake, you're talking about petabyte scale data set. And if you say that I'm going to lift and move this data to another system, good luck with that. Good luck with that. First of all, it's going to be cost prohibitive. Second, it's not practical. You really need to start thinking about how to build something where your data and your compute engines are totally independent. Because not a single engine can fulfill all your needs. You really need to start thinking how to leverage different engines according to their merits. One of the things which I'm going to go through that, once you have those data sets, I'm going to walk you through a three-phase kind of approach. You don't need to kind of boil the ocean and say, oh, I'm going to go all the way to the run phase. You should be designing your system and architecture to keep that in mind, that I'm going to serve that. That's my end goal. But start with the baby steps. Start with first step is that get all the data at one place. That's your base thing. If you don't have a data, no matter how good machine learning or deep learning you put it in, it's not going to work. Because your algorithm is as good as your data is. The key thing, you need to make sure the data is well curated, it has a data quality, all those things are in place. So use the crawl phase to build the foundation. And when I'm talking about what is the crawl phase look like? So crawl phase is that I brought all these blue data sets into my cluster, into my system, into whatever technology you want to use it. I'm bringing that into a system and leveraging some technology. It could be SQL based, it could be Spark based, it could be anything, where I leverage that information to leverage those rules which has been dictated by regulators that do these kind of checks. For example, if a person does X number of transactions in a month, flag that. If a transaction is more than 10,000, flag that. All those things are kind of rules. Think about that. And that's why I'm saying you have to have a system which has a rule engine. And that's your first phase. What essentially is going to give you, it's going to give you a alerting system that leveraging that system, now you are getting something which will show you that this could be a fraudulent activity. But the biggest problem in this system is that all the investigation is going to happen manually. All the investigation is going to happen manually. And what is the impact due to that? That first of all, each case is going to get handled totally differently. Because if there are 5 people and if you give them the same problem, you will not get the same output. Unless they have a very clear guideline and they're clicking through those. And second thing is that a lot of those things which the data is too much, they can't even get into too much detail. When you are developing a single view of views and views on top of that, how are you going to visually represent that? because data informations are too much. And these are some of the limitations you will see. But keep in mind that this is your foundation. If you get to this point, actually you're better than probably 60% of the people in the world. You're better than 60% because you have achieved a foundation which has all your raw data at one place. Remember when one of the main limitations when we were talking about segregation of data. Data is in too many systems today. If you have data in 10 or 20 or 30 different systems, you cannot build an effective AML, period. First of all, the timing of update is going to be totally different from each one of them, and the data format could be different. You can't have a single tool which you can use for that. So build a foundation, bring the data, do some data quality, normalize that, so I can give to a system which work on some rules. Rule could be written in Spark, could be part of your ETL job. Rule could be written in SQL. It could be as simple as that. And then you need a very rich UI to kind of deal with that. Second phase, and this is where it starts getting interesting now. You already have a data, and you already got all the data into the system. Now, I want to kind of get rid of a lot of human activities which people are doing. I want to automate that, and I want to normalize that. Because using the first phase, I developed a database where now I have a patterns that these are fraud activities, these are the regular activities. I'm leveraging that information as a foundation in this phase. And what essentially I'm doing here is that I'm driving now a lot of metadata out of data itself. Because I have a sample, I have learned from the system through humans that this is the analysis came out and this is how they classify information. Now I am getting into kind of supervised learning, right? When I'm applying a machine learning here, I have my now test data. I could have more data which is coming on a daily basis. That's my training data. I can figure that out, what essentially is happening. It could be, but one of the biggest problem with this system, what you see is that your accuracy might be still only to limited extent. Why is that? Definitely, that's one of the reasons. But keep in mind that when we talk about that, you are still going after known cases. You are building your algorithms based on the data set which human has flagged that is a fraud. So machine learning is going to be as good as your data is, as good as your test data is. So, but this is a great leap towards that. What essentially is happening, now you're cutting the 100% human time to almost 30 to 40%. You still need some human to figure that out, because within your UI now you can categorize them with high confidence, low confidence, and semi-confidence that these are fraud activities. Go figure that out. So, and why I have mentioned here unsupervised learning. That could be your next step, because you want to apply on the same data where you are applying some test data and metadata to come up with your fraud transactions. You could use the same data and apply some unsupervised learning and try to compare and contrast the output. And that will kind of give you the next level of detail. Now you are trying to kind of get best of both worlds. You're trying to figuring out that what are the patterns in the data? which are telling me that these are fraud activities? Are they matching with my test data? Are they matching with my trained data set kind of thing? So these are some of the potential machine learning algorithms which you can use. And if you ask me which algorithm I should be using, I would say that it all depends. When you're building this kind of complex platform, you might be using more than one. Because when you are doing KYC might have its own machine learning algorithm applied. When you are doing the transaction analysis across geographic, it might be leveraging a second level of machine learning. This is your ultimate, that's where your goal should be. This is where you should be thinking about that I need to go. And in this scenario, if you look at that, you are getting into a completely deep learning and neural networks. So you got your data now. Over the period of time, now using humans, using machines learning, you have developed some good patterns. Leveraging that information along with deep learning will give you optimal solution. Because in this case, if you look at that, I am not feeding anything which I know that this is a fraud. Machine has to figure that out. So this is where you really want to kind of get to. This should be your end goal. And once you start building something like that, the one thing which you're going to really realize that, oh, when I build my AML platform, this is not only good for just AML. I can do a lot more with that. I can do any kind of compliance reporting. I can do a data discovery on that same platform. And I could take the whole institute to the next level. That's the beauty of open platform, that you're not, once you brought the data at one point, you won half of the battle. It just opened the door for you for multiple activities. So just to summarize, this is essentially what you need to have when you are building a AML-based kind of solution. You want to make sure that you automate your due diligence and apply on KYC data set. You want to bring all the data set in a normalized format over there. You need to have effective case management. You need to kind of then have a capability to apply different kind of machine learning and deep learning. And this goes back to, again, why you want to keep it open platform. Let's assume that if you bought some out of the box package, it has certain level of deep learning or machine learning algorithms available. But how are you going to update that? Machine learning is progressing. People are now talking about deep learning. People are talking within deep learning, they're talking about neural network, TensorFlow, how to do it more and more data set. And everybody wants to kind of have a complete open platform that I'm ready for tomorrow. So those are some of the things which you really need to think about when you are building this system. And another reason why you need to think about that, if you look at that, where your end goal is, where you want to be in your data size, that in a crawl phase when we were there, you're still doing a descriptive and diagnostic kind of analysis. That something bad has already happened. You haven't stopped that. Ultimately, in the second phase, you got into predictive. But where you want to be, you want to get into prescriptive mode, where your system is deciding for you that if something is a fraud or not a fraud. And why is that very important? Not just because you want to kind of automate, you want to get into real-time phase. The reason is that your data is growing. People started with gigabytes to terabytes to petabyte. Now people are talking about exabytes and zettabyte level, because that's where the big data and your IoT data is coming into picture. Can that data human handle that? Absolutely not. This is why you really need to think about how to get to the run phase. And this is just a kind of another summary which talk about why this kind of platform should work, because it's open. It is not geared towards a particular time frame. It is geared towards a problem solving and keeping it open for you. At the end of the day, the same platform which I was talking about not only can solve one type of problem, but it can solve the multiple use cases and problems. With that, I'm open for question and answers.
The next session starts in 6 minutes.
Yes, so we are.
I know, the next speaker starts speaking in 6 minutes.
Okay.
We already got people waiting to come in.
Okay, so just I can take 1 or 2 questions if.
If you can send us a slide deck.
Sure. I agree. Thank you.
Please raise your hand so I can scan you here.
Thank you.